So in the last video, I left off talking about how carbon bonds, and I said that carbon always likes to have 4 lines coming off of it, otherwise known as 4 bonds. And so you can see that here there's 4 bonds coming off of this carbon, there's 4 bonds coming off of this carbon, and even when carbon double bonds, there's still 4 lines coming off of each carbon. So you will always see carbon do that because it's trying to share 8 electrons overall. Again, when there is 2 lines like this is called a double bond because it has, 2 bonds together. And when it only has 1 line, it's called a single bond. You can also have carbon form a triple bond, which looks like it having 3 lines off of each other. I don't know why it keeps disappearing. So here's a picture on Google where you have each carbon is triple bonded to the other carbon. So this carbon has, again, it still has 4 lines coming off of it. 1, 2, 3, 4, and this carbon also still has 4 lines coming off of it. 1, 2, 3, 4, except now 3 of the lines are shared between each other. So this is a single bond, double bond, and triple bond. Notice how, again, always, there are only 4 lines coming off of any carbon. If you draw 5 lines coming off of it, it's wrong. Or 3 lines, it's wrong. You always have to have 4 lines. Yeah. So, naming organic compounds, or otherwise known as hydrocarbons, your reference table helps a ton. So there are 2 tables that I am going to show you how to use right now, and that is table P and table Q. Alright, so let's start with table P. So if you have a carbon compound that only has 1 carbon in it, it has the prefix meth, so it would be like methane. If you have 2 carbons in it, then it's going to have the prefix eth, so it would be like ethane. So let me just show you a drawing of what that looks like. So 1 carbon, and it has 4 bonds. It's going to start with meth. 2 carbons bonded together, and it also has to have 4 lines coming off of each one. That's going to start with eth. 3 carbons, each with 4 lines coming off of it. That would be prop. So it always starts with this prefix depending on how many carbons there are. To figure out what the name ends with, you need to look at table Q. So, I know it looks kind of complex, but it's really easy to read once you get the swing of it, and then you'll always get it. So, let's break it down. So basically, if you have only single bonds between the carbons, it's always going to end in ane. If you have double bonds between carbons, it's going to end in ene. And if you have triple bonds between the carbons, it's going to end in ine. So, let's try some problems. Let's do it. Alright, we're going to start with problem number 1, and we're going to try to name this compound, this hydrocarbon organic compound. So, let's start off. We have to figure out which prefix we're going to use before we figure out the rest of the name. So how many carbon atoms are shown here? I have 5. So because I have 5, the name's gonna start with pent. Then I'm gonna go down to my second chart, table Q, and I'm going to look to see what kind of bonding it has. So it looks like there's only single bonds. I don't have any double bonds or triple bonds in this molecular structure. So I know that because there's only single lines between each carbon. Unlike in the second picture, you can see this is a double bond. But up here we only have single bonds between all of our carbons. So because it only has single bonds, it looks like this guy, the closest. So its name is going to end in ane. So the name of this structure is pentane. Pentane. So the table Q is where you get the ending of the name, and it's either always going to end in ane, ene, or ein. And that's it. So let's try the second one. So here I drew, sorry, that's on, let me make that prettier. So here I drew another organic hydrocarbon for number 2. And you could see it has 1, 2, 3, 4, 5 carbons. So it's actually also going to start with pent. The difference between this organic molecule and this one is that it now has a double bond between 2 of the carbons. So, because it has a double bond, its name is going to end in ene. So number 2 name is pentene. So that is the gist of how to name an organic compound. You'll see that there's more information also on table Q. It shows general formula stuff. So I'm going to talk about how to figure out the general formula for number 1 and number 2. So when we're looking at the number 1, really all these like little lines that don't seem like they're going anywhere, they have hydrogens. So these are all hydrogens, and I just was lazy and didn't write them. It's implied that it's hydrogen if there's nothing at the end of the line. Like, there's obviously a bond, so there has to be something on the other end of the bond, and it's always hydrogen if you don't write anything. So I'm just gonna, at the end of all of the bonds, I'm just gonna write H's. So the general formula includes the numbers of carbons and the numbers of H's. So let's go through and try and figure it out. So I'm going to just start by just counting, and then I'm going to try and figure out how to do it by not counting and using the general formula. So just counting for number 1, I have 1, 2, 3, 4, 5 carbons. So our general formula is going to be C5 and then H something. It always starts with the carbon first and the hydrogen comes second. So the number of H's we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 hydrogens. So this is the general formula, also known as molecular formula. And in this case, it's also the empirical formula. In case you don't remember what the difference is between molecular formula and empirical formula, just quickly on the side, note what they are. Molecular formula is the more complex one. It's what its actual formula is, and empirical formula is simplified. Simple. So because C5H12 cannot be divided by any number to make it simpler, it is both the simplest it can be, but it is also the actual formula, so it is the molecular and empirical formula for the compound. which also is now known as the general formula. Alright, so this is our structure for 1C5H12, but let's see if we could figure out how we could have gotten that by just looking at this formula right here. So we know it's an ane because it has all single bonds. So it's going to follow this formula. It's considered, its category is an alkane because it only has single bonds. And so we knew from the start it had 5 carbons. You have to know how many carbons you have, and then you could figure out how many hydrogens you have based on that. So if you have 5 carbons, then the way you figure out how many hydrogens you have, because counting them is just like a pain in the butt, especially when you get to like really large compounds, is you use this little formula down here. So N was 5 because we just said it was 5 because you had to count how many carbons there were. So we know N is the number 5. It's kind of like X, it could be any number, but in this case we figured out that it was 5. So here you're doing, for the hydrogen, 2 times 5, because you assigned 5 to N. And so 2 times 5 is 10, plus 2 gets you 12. So look at that, we have C5H12, which is the same formula as up here. So we know we did it correctly, and we didn't actually have to go in and write all the hydrogens and count all the hydrogens, because chemists are lazy, if we're being honest. Let's try to figure out the general formula for number 2 without going in and counting all the hydrogens. We know it's an alkene because it has a double bond, so its category is alkene because of the ene ending. We know its actual name is pentene because it has 5 carbons. So again, you're going to start off with C5. Now for the hydrogens, it's just 2 times N, and again N is 5. So in this case, 2 times 5 is 10. I can count. So we just figured out what the formula should be for this guy. And to double check it, let's go back in and count. So we have 1, 2, 3, 4, 5 carbons. So we have C5, we knew that. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, it worked! C5H10. So, easier than counting, you could just use this formula. But, you know, if you want to double check, you can always go in and count. So, yeah. But if I could give you a question where I say, alright, I'm giving you a compound that has C5H10. Is it an alkane or an alkene? You would have to figure it out by comparing it to the formulas here. We'll do some practice problems with that in the next video.